My name is Anna Steffi, and this is for Physics 172 Distant Learning Summer, and we are Group 19.
My name is Zachary Barnett, and I'm part of Group 19.
My name is Alana Jadwalis.
And so this is for recitation 6, the energy principle. First, we looked at this, which was present in our lectures as well. I'm pretty sure we all got the same response. I see Zachary's here. What did you guys get?
Yeah, I mean, I got pretty much, the only thing that's changing here is the direction, since magnitude would be constant, since the speed is constant. And then the force perpendicular, which is the magnitude of directional change, is 1.8.
Yep.
Yeah, it's also
I got the same thing. So part 2, it says what magnitude of the net force acting on the block? What is the magnitude of the net force acting on the block at the time? And you have 1.8 newtons. I got the same thing. Did you get the same thing, Alana?
yeah.
Awesome. Really straightforward. I got the same idea. What objects in the block's surroundings are interacting significantly with it at that time? The only object interacting directly with the platform. No frictional force. Oh, you didn't put gravity here.
Oh, does that count as an object? I kind of tripped up a little bit.
Oh, I guess.
Because I mean, if it said like forces, I would have put gravity, but it said object, so I was just wasn't sure.
I'm gonna still want to put it personally.
That's cool.
Just because, like, I guess like this is a little stupid, but to draw an arrow, to draw like a complete, like, obviously arrows representing the forces on the net force, like the gravity's like impermanent.
Yeah, I guess you're right. That makes sense. If we're talking about that force. Yeah.
Even if it's not there, I doubt we would be taken off for it. That was number 3. Yeah, I got force. That you have normal force, which I do not have. Oh. If the block speed at the instant shown was 3 meters per second, but increasing instead of remaining constant, would the magnitude of the net force on the block be less than, equal to, or greater than it was before? Would its direction be different? If so, describe how.
Yeah. So my answer was the magnitude overall would increase, because not only would we have the directional change that we talked about before with the perpendicular force, but we'd also have to take into account the parallel force, and then adding those together, the F net would also increase, and then the direction would change slightly. So normally the direction of the force, net force, would be pointing directly towards the center of the circle. Taking into account parallel force, that net force would be taken to the right a little bit, kind of closer to the edge of the circle.
Yeah, I agree. On step 5, study rotating bar 30 degrees from vertical. Looks like we all got the same. I have one of these being negative. Why? Oh, if this is it, like if this is the angle from 30 degrees to vertical and this is the 90 degrees, this tensile force is acting downward in the y direction, not upward. The y component should be negative. Does that make sense, or do you disagree with that? Or does it change later on? Did I miswrite it? I don't have my calculator with me. 2 Well, both of you have positive, so yeah, negative. I'm just gonna have to get my calculator.
Yeah, I'm not quite sure about this one, honestly.
Oh, okay. I just have to figure out. Negative 1.8 multiplied by cosine of 30 degrees equals minus negative 0.98 is a negative number.
All right, let's do that.
And that makes sense right here as well. That this would turn negative. And then problem 2. 30 kilogram child rides a playground merry-go-round 1.4 meters from the center of the merry-go-round, makes one complete revolution every 5 seconds. How large is the net force on the child? In what direction does the net force act? You get the same. You get the exact same answer. Speed is constant, so is 0. The direction is to the center. Awesome. Does everybody like everything in the document?
I'm happy with it.
All right.